Basis weight is one of the crucial factors that determines the quality of nonwoven fabric. Today I will show you how you can optimize your nonwoven production by measuring and controlling the basis weight. Let's jump right in. Hello and servus from Bavaria. Welcome to our new Marlow MCAST. In this YouTube channel, it's all about measurement, control and automation for moving webs. If you are new to our channel, don't forget to subscribe. My name is Matthias Wulbeck. I'm the product manager for web gauging systems at Marlow. For more than 75 years, Marlow has been active worldwide in the field of running fabric webs. In quality management systems, web process control, and web gauging systems, we have an experience over 25 years. So we know exactly where the shoe pinches and what solutions are available. In our MCAST series on the topic of nonwovens, we would like to show you the online measurement and control of important parameters. Nonwovens are designed specifically for their intended use and must adhere to exact technical parameters to work perfectly in their final destination. These parameters are significantly influenced by the physical properties that result during production. The basis weight, the moisture content, and the thickness determine the decisive properties of the nonwoven. In today's video, we show you how you can optimize the nonwoven production by measuring the basis weight. Talking about the basis weight, we look at two different physical principles. The most well-known way to measure the basis weight is the use of a so-called beater gauge. A beater gauge contains a radioisotope, which can be a krypton 85 or a strontium 90, depending on the weight range, and the radiation penetrates through the web. And according to the basis weight of the web, the radiation is reduced on the receiver. The receiver detects the loss of radiation energy and calculates very exactly the basis weight in grams per square meters. So this is, in simple words, the function of a beater gauge basis weight sensor. But one very important thing we have to consider when we use a beater gauge. It requires radio safety measures from the customer. That means the user of a beater gauge must have a radiation safety officer in his house, and second important point is he requires an approval from his local authorities. If you look at the measuring beam, then we can notice that the beam comes out in a cone shape from the emitter, where we have the source, to the receiver. And this cone-shaped beam leads to the fact that the radiation is scattering according to the position where the web is in the measuring gap. A simple detector would get disturbed by this effect, which leads to a different measurement if the web is changing the position inside the gap. Marlow is using a double ionization chamber. That means we have two chambers, one in the middle and a big one with an outer rim. And we get two signals. This makes it possible for us to calculate the difference when the web is changing its position, and we compensate this effect so we will always have a stable reading of the basis weight. The alternative for the basis for the beta gauge is an X-ray gauge. It works very similar as a beta gauge, with the difference that the radiation comes from an X-ray tube. And this X-ray tube can have different energy. We have three sizes. One is below 5 kilovolt. Another stronger one goes up to 15, and the strongest one up to 50 kilovolt of energy. And the very interesting thing is that the small one with 5 kilovolt is license-free in most parts of the world. That means no radiation safety officer, no approval from the government, no special requirements for importing the sensor, or even deposit the sensor when it goes out of operation. The difference is that the weak X-ray sensor is more sensitive to the single component mass. That means if we have a mixed material containing heavy and light fibers, for instance, glass fiber and carbon fiber or polypropylene fiber, so they have very different masses, then we need a very accurate calibration of the sensor, because it reacts on the component mass of the single fibers. On the other hand, the beta gauge is much less sensitive to this effect. So when we compare both, then we can say the beta gauge provides us a very stable and easy to use measurement for the operator. But the negative point with the beta is the requirements for radiation safety. While the weak X-ray sensor does not require any measures from the user, but it takes more effort for the calibration. Another difference is that the X-ray does not have a cone-shaped beam, but a very focused beam on the web. Here we have made a test with photographic paper. We have used a slit source aperture and with 5 to 17 millimeters. And when we compare the measuring spot on the web, then we get a very focused spot with the X-ray, while the beta is scattered like this, so it gives us a bigger measuring spot. But this can be an advantage when we measure non-woven material. So far for the theory. Now let's take a look at practice. Hello everybody, and welcome to the Marlow showroom. This is a very busy place, as you easily can see. We do a lot of research and development on our machines, and we can also make sample tests with customers' fabrics that we put on our machines and show the possibilities for the measurement. And here we are at our QualiScan wet gauging system. And I may introduce Christian Matthias to you. Hi, Chris. How are you doing?
Hey, Matthias. Nice to meet you.
Very well. Christian, what do you have prepared for us today?
Today I'm using our QMS gauging system for measuring some basis weight at non-woven products. Customer request sample testing report will be made afterwards. And today I'm using our FMX X-ray based sensor.
So this is the X-ray system that runs without license and radiation safety measures from the customer.
That's correct, because it's under the voltage of 5 kilovolt. You don't need a radiation manager in your factory, and you can run it from every operator is allowed.
And what about the accuracy of such a system?
The accuracy is very high because we use a very small measuring spot. In this case, the accuracy can reach up down to 0.5 gram per square meter. So it's very accuracy and very good for the resolution of the product.
Okay. So, and now we have a non-woven sample in the scanning frame. And what do we see on the screen?
Here in the visualization of our software, the measurement, the sensor scanning results are shown in 3 different ways in this case. So these are the most common used information bars, also a lot of use by our customers. Here we can see it in the top, the cross profile of the product, so you can see the result of the basis weight measurement over the product width. In the middle, we show and visualize. We show some kind of statistic reports, the accuracy or the variation coefficient. And in the base, also a good information is the length of the product, where you can clearly see shown by different colors, is your product too high or too low at the basis weight measurement, and therefore do the operator of the production machine need to adjust some settings to get better results or more averaged results.
And what is the red color in the cross profile?
Oh, the red color shows me the result if some weight is out of tolerance. So every customer has a tolerance for their product, and here you can easily see at one fast view during production that maybe at some areas in your product the tolerance isn't that good, that you can reach a 1A product, and therefore you have a very fast shown result and can adjust or react.
That's great. And all these data that belong to one specific product can go to the memory, right?
Yeah, that's of course. Also, the memory will be saved 2 times in our systems. Also, a backup will be made. And of course, you can create some PDF and print server protocols if you, of course, need the report in paper form. That's both possible.
Okay. So then please let's do in the next step, make the measurement with the classical beta gauge with the isotope Krypton 85, just to see if both systems work in same or at least similar way.
Yes, of course. I will make some adjustments and then we can use our other weight
Great.
measurement system.
Thank you. Okay, Chris, now you have changed the sensor for the radioisotope Krypton 85. And this is working now with the classical beta gauge.
Yes.
We can see a very similar profile. The measurement is a little bit different. I guess this is because of the different measuring spot size.
Yeah, that's correct. So also here our visualization works like I mentioned before for the FMX system. We do have the cross profile in the top. Also, we have the colored marks for the out of tolerance results and values. Also the statistic values as well, and the over the whole production roll measured values, also very good, and with a quick view recognizable results of the measurement.
Okay. And in daily calibration, I think the beta is a little bit more easy to handle.
That's also correct. The beta doesn't matter if you have a product out of more than 2 materials, because it makes a very averaged good result measurement. The FMX is a bit more sensitive for more than 2 material products, for example, but the beta system doesn't matter. He measures everything, I would say. Also, in this case, our non-woven product.
And what is the maximum weight that a Krypton 85 can detect?
So it depends, but mostly it can handle weights to up to 1.1 kilogram per square meter. Then in some cases it can reach 1.3 kilogram per square meter. It depends also on the product. So the dense weakens the signal. That's in this case matters what the product it is.
And as a result of our test today, we can say that both type of sensor, the X-ray as well as the beta, will show very good results, and they are both applicable to measure non-woven basis weight.
Both sensors, both systems are capable of measuring the basis weight for, in this case, the non-woven. And we can clearly see that the results are similar to each other, and that it depends on what purpose you want to use the sensor, and if you have, of course, trouble with the radiation manager, for example, at the customer's facility. But in both cases, we reached a very positive result, and that's common for our systems and our measuring systems.
Okay, Chris, thank you very much for today.
You're welcome.
See you next time with the humidity sensors.
It was a pleasure to explain you the system, and I hope you come back soon.
Be sure.
Okay. Goodbye.
Thank you very much for watching. Did you like the video? Then give us a thumbs up. Don't forget to subscribe to our channel. Then you won't miss any of our new videos. We would love to hear your comments and suggestions. So put them in the comment section. Don't miss the next episode of our MCAST non-woven series. I'm looking forward to seeing you there again. My name is Matthias Wollbeck from Marlow. Have a nice day and goodbye.